Hi, today we're taking a look at blood vessels in histology. First, we'll take a quick look at some schematic, classic structure of arteries, arterioles, veins, venules and capillaries. Then we'll have a look at some easy examples on histology slides before moving on to some more difficult examples. Arteries carry blood away from the heart and veins return blood to the heart, with capillaries in the middle to supply the tissue in between. Small arteries and veins are called arterioles and venules respectively. All arteries and veins have three layers: the tunica intima, the tunica media and the tunica adventitia. The tunica intima is the closest to the lumen and consists of just the endothelium. In large arteries there's a layer of elastic-rich collagen just underneath the endothelium too. The next layer is the tunica media, which is composed of smooth muscle. In large arteries there are more elastic fibres here. The tunica media is much thicker in arteries compared to veins. The final layer is made of collagenous connective tissue. This is the tunica adventitia. In larger vessels it contains the vasa vasorum. These are blood vessels that supply the tunica media. So let's have a look at some blood vessels in tissue sections. This slide is a section of heart from a pig. At low power we can pick out two large blood vessels. There's one here and one here. This is a lovely typical section of an artery stained with Mason's trichrome, which highlights collagen with a turquoise stain. We can see the layers that we talked about in the schematic relatively well. The endothelium is this single layer of cells lining the inside of the lumen, and just underneath it there's some collagen-rich tissue. Here we can see the tunica media is formed of smooth muscle. Each of these sausage-shaped things is a nucleus, and then around them we have the cytoplasm. We can't really make out individual cells very well because they all kind of merge together, but we can certainly see the typical cigar-shaped nuclei of smooth muscle cells. Outside the tunica media we have the tunica adventitia, nicely stained with a trichrome in a lovely turquoise colour. We can see more cell nuclei here, which are probably fibroblasts producing the collagen tissue. Just next to the artery we can see a vein for comparison. Again, we can tell this is a blood vessel because it has some red blood cells on the inside and this amorphous eosinophilic material, which is the plasma. If we zoom in, we can make out the cell nuclei of the endothelial cells lining the blood vessel. There isn't really much of a tunica media. We can't really see very much smooth muscle. And then on the outside, we have the tunica adventitia highlighted again in turquoise. Let's have a little bit of a hunt around for some arterioles and venules. If we look within the heart muscle, we can see two smaller blood vessels. Now, these ones don't have blood cells in them to help us identify them, but we can see some of the other typical features. There is a layer of endothelium. We can just about make out the nuclei. Unlike the larger artery, there's not a layer of really distinct collagen underneath, but we can just about make out the basement membrane as this tiny grey line underneath the endothelium. Next there's the tunica media with its smooth muscle cells. Again, you can see the sausage-shaped nuclei. And then on the outside we have the tunica adventitia, again highlighted in turquoise, which is merging with the connective tissue. Just next to those two arterioles there's a venule. And again we can see similar differences to that we saw between the artery and the vein. We can tell it's a blood vessel because it has this amorphous eosinophilic material, or the plasma. Maybe these were once some red blood cells down here. And then lining the blood vessel we have this lovely endothelium here. Nice squamous cells just demarcating the lumen very nicely. There's not really much of a tunica media. Maybe this is a smooth muscle cell here, maybe another one here, but not much to speak of, which makes it a venule rather than an arteriole. And then tunica adventitia merging with the surrounding connective tissue. There's a cerebellum here and brainstem here, so we're going to have a look and see if we can't find some capillaries, because we've not really had a look at those yet. We can see some veins entering the cerebellum here from the meninges. So if we go into the white matter we should be able to find some smaller blood vessels. And indeed we can find some very small blood vessels indeed. So these are capillaries here. We can make out some red blood cells within the lumen. Some single endothelial cells. And you'll notice there's no real Tunica Media or Tunica Adventitia to speak of. They're just formed by the endothelial cell wrapping around them. Perhaps they're a little bit more convincing here, for example. You can really see that there's only just enough space for one red blood cell to squeeze through the lumen. And here's the endothelial cell again forming the capillary. I just saw a nice example here of a venule. So it's got a slightly bigger lumen than a capillary. Endothelial cells, but no smooth muscle, right next to an arteriole. And you can really see the difference here between the thickened Tunica Media with its smooth muscle. And this, look at this beautiful capillary here. You can just see the single red blood cell squeezing through the lumen and the endothelial cells, or at least the nuclei, forming the body of the capillary. I mean, look at this. This is beautiful. Single red blood cells fitting through a capillary. So those were some quite easy examples. They fit the schematics pretty well. What about some more difficult examples of blood vessels? The tricky ones where they're cut in oblique sections or in orientations that you couldn't quite expect. So this is a section of duodenum. I think it's from a horse. And in the submucosa we should be able to find lots of blood vessels. And indeed we can see some here. Here's a nice vein, but then we've got this kind of odd looking structure here, which is a vein that's cut in longitudinal section. So we can't really see any red blood cells to speak of, but maybe these little bits of red might be some lysed blood vessels. But we can tell that it's a channel lined by endothelial cells. And then you might be able to catch the odd smooth muscle cell. For example, this one here is quite convincing as a smooth muscle cell. Now, because it's cut longitudinally, we might get some of the smooth muscle that was on top of the vein. So this is probably a smooth muscle cell in the tunica intima on top of the venule that's just been sliced in the longitudinal section. If we follow it along, we'll get kind of an odd structure like this. This is a blood vessel in an oblique section. I mean, we can see a bit of a lumen over here with endothelium and tunica media. But then all of this is tunica media as well, but cut in an oblique section. So we haven't gone into the lumen of the blood vessel, we've just sliced along the top of it. Here's another lovely example of a blood vessel cut in an oblique section. This is tissue from a cat's cheek, so we've got some oral mucosa over here and then submucosa underneath it. We have a little nerve running along there and some skeletal muscle here. And then we have this rather odd looking section of some cross-hatch cells. They look like smooth muscle cells because they have their cigar-shaped or sausage-shaped nuclei. And if you don't believe me that it's a blood vessel, if we follow it up, eventually we enter the lumen as it just changes plane of section, and we can see that it's a lovely blood vessel with red blood cells in the lumen, lovely endothelial cells in the tunica intima. You can really appreciate them there. And then some smooth muscle but cut in a different section. So rather than having longitudinal sections of the nuclei giving the nice sausage shape, they've been cut through the middle. So we've got round nuclei instead. Now, I mentioned that in some sections you might get some tortuous blood vessels that kind of go all over the place. Well, this is a section of skin from a cow that was infected by a parasite called Onchocerca. And in the tissue around the parasite, of course, there's going to be lots of inflammation and maybe some healing going on. So we can expect to see lots of blood vessels within it. So we've got some lovely arterioles here. There's a nice one here with its endothelium again, forming the tunica intima, tunica media with its smooth muscle, and then this is stained with H&E. So unfortunately, we don't have the lovely turquoise colour for collagen. It's just this kind of reddish pink. But we can appreciate the Tunica Adventitia merging with the surrounding connective tissue as well. So if I have a little bit of a scroll around here, we'll start to see some blood vessels that are cut in unfortunate and odd section. So here's another little arteriole that's just been caught in a bit of an oblique section. We've got some red blood cells in the lumen, endothelial cells, and then the tunica media we can just make out as these cells around the outside. I think if we pop over here, again, we've got collagen with some activated fibroblasts, some inflammatory cells responding to the parasites, and then we've got this kind of odd looking structure, and the only hint really that it's a blood vessel is that we have this red blood cell in the lumen here. And if you're used to looking at blood vessels, you'll identify these as endothelial cells. They're quite plump because they've been activated by all the inflammation. And then smooth muscle, tunica media around the outside, and then Tunica Adventitia merging with the connective tissue. So we can just follow that blood vessel up as it's been caught in a bit of an oblique, kind of almost longitudinal section. Here it is, maybe giving off a little branch, a little arteriole going off into the tissue over here. So that's it for now. I hope you're all clued up on how to spot blood vessels on histology slides now. But there are still some pitfalls. Why don't you check out this quick video about some structures you might confuse with blood vessels and how to avoid those traps. Thanks for watching, and until next time, goodbye.